She's taking care of
when I was young engineer,
Indian market.
listen, this is a very good story. When I was a young engineer, I was taught that membranes are used only in one direction. Reverse osmosis membrane are used only in one direction. Correct? There are a lot of people who know RO membranes. They say one direction only, never the reversal. Never the reversal. 35 years it took me for me to find somebody like Boaz. Today he'll talk about flow reversal. How to reverse the flow in reverse osmosis membrane. Ladies and gentlemen, let me introduce to you Boaz Shitzer. Boaz has been at the helm of ROTEC since 2012, initially serving as lead investor and chairman on the board, and stepping into the role of CEO in 2023. Under his leadership, ROTEC has strengthened its position in the global water treatment sector, advancing its patented flow reversal RO technology to deliver greater efficiency, sustainability, and market growth. With more than 15 years of leadership experience in the water and chemical industries, Boaz has held senior positions at AST and the Shitzer Chemical Group, where he developed deep expertise in innovative membrane technologies and environmental solutions. He also brings a proven track record in marketing, sales leadership, and international business expansion. Boaz holds a BSc in economics. To everybody's surprise, he is not from scientific background, from Tel Aviv University, and an MBA from City University of London in UK. So over to you, Boaz. The floor is yours.
Thank you for your introduction. Yeah, I'm really happy to arrive here in India and in this IFAT exhibition. Like being introduced, ROTEC is a novel technology developed for application in desalination, and we can go now and learn together a little bit about our activity in this arena. We specialize in high recovery desalination, and we are looking at becoming a partner in making a better future. We are talking about sustainability, recovery of water and resources, and also improving water use all over the world. So ROTEC started in 2009 as a startup company or a spin-off from the Ben Gurion University, and I've seen the technology first on a bench scale. We've seen a pressure vessel that was reciprocating at 2.5 inch, and we bought the idea and started to invest in this, and now, let's say 14 or 15 years down the road, we have a working platform, working solutions all over the world, and we are considered leaders in industrial reuse or wastewater reuse, desalination of high efficiency of brackish water. And we have more than 85 installations worldwide where our system working, collecting data, sharing know-how, and making good water. And we patented our process in 2 areas, and we'll share it with you in a minute. So, ROTEC team is based in Israel. We also have a daughter company in China and in the US. And we are serving and designing our machines, doing piloting, doing process all over, including this is the island of Malta that we built there, a big plant. We are now doing more activity. So technically, going into our services, we are designing the technology around our patents. We are able to service and do modeling. We can design the machines, and we do partnerships like the one we are doing here in India, and we are working with different technologies. One of our skills in this team is also to do retrofit services. We are spread all over the place. We have installations from Papua New Guinea one side and Chile on the other side. So technically we can work in Israel like 20 hours a day and still have some time with customers calling us. Some of our customers are well known. Some of them don't allow me to put the logo, like Intel, but we are working with a lot of them. Well, this is the fact of the matter. Coming to India, it's a continent. For those who don't know, a lot of this map shows the water risk area or lack of water. And one of the things ROTEC brings to the table is a lot of water reuse projects. How to create from wastewater good water at affordable price, reasonable technology installation. And I think this is where we are targeting. But this is really an area that we didn't have installations yet. We have now 2 going. And I expect this to be with our partners a success story here because the demand is exceeding everything we have seen. In the last, I think, 8 years, we've been talking about high recovery, let's recycle, it's too expensive, let's wait, let's think about it. What happened in the last 2 years is explode in our business, not only us, everybody you can see here around. What we are trying to do, I will explain a little bit about the technology. We're looking to improve the reliability and the efficiency of the desalination process. Everybody is familiar with these problems. Membranes are fouling. It's like laundry. You take your shirt, you clean it too much, it loses its performance, appearance, permeability, membrane rejection. All these problems are around this phenomena. And what we are trying to do is we are trying to take this into an area where we are reducing either the feed or improving with the same feed the high efficiency. So you can see what happens to our brine. It's cut by almost half when you are just adding 10% recovery. Speaking about footprint, talking about our collaboration with the environment, this is a very strong example. And also the cost. What cost maybe a few years back to do 80% or 90% now is reducing. We are improving the efficiency of the costs related to high performance. Like I said, retrofitting. What you see here is an example from Singapore, and I will show you, but we're able to take standard design, retrofit to ROTEC, we can immediately have better performance. And these solutions are resisting to scale, fouling, based on some performance. What is flow reversal? Technically, you see a pressure vessel here. Works. We are charging the last membranes. It will start to fall. It will be precipitation on the membrane. So, when all this is done, what you see is the membrane surface start to precipitate. You start to see the fouling that is avoided by scalants, etc. But it's not completely eliminated. It's built up. Compared to other technologies, this is a standard or static design. Our design, all these fall around, is more or less a static process. Nothing is moving. Everybody sticks on the membrane. So we developed a method to take this and get the scale washed away, change through the pressure vessel. So technically this would be our feed. When we are changing the direction, it will start to scale, then we are changing again. We are playing with the induction plant. Now what you see on the softwares of our scalants also, they have their own formula doing it. When we added ROTEC into the equation, we were able to increase the recovery by avoiding these traps or recovery problems that we find in standard design. Every hour, 2 hours, the whole change in the orientation of the pressure vessels start to distribute the burden between the first, the second, and the third stage. So not only the last membrane that see the brine valve is charged with all the debris. We are making a better usage of the membrane surface area. And we also mastered this further because what we are doing also rotation. Not only the flow reversal internally, we are reciprocating the whole plant. You can see how we are mobilizing within the skin the formation. So we can go up, we can go down, and this is our patents. Around these two patents, we developed our technology. And we have seen earlier here a presentation by ROTEC. They're able to do 96, 93% recovery, 95, but they need 6 or 7 stages. We are able to do it with 2 or 3. What you see here is a typical 3-stage machine that can do 90, 95% recovery with the hydraulic kit and our design. So we will basically start to switch through automation, come to this kind of well-established process where we can eliminate this phenomenon. This LSI factor that is very common in our industry is a good factor for us of how we can clean the membranes, and we are doing actually cleaning. We are charging the highly saturated water, and when we are changing the flow, we are undersaturated, so we are cleaning the membranes. So that's our technology. I want to show you a short animation. So we have taken the patents and we put it into a real-life machine. This is a skid that now our partners MWTS is building now for a semiconductor facility here. This machine now will take individual pressure vessels and start to reverse the flow internally. And when we are doing this, we are being able to avoid the standard clogging that you can see on a conventional machine. So this scaling that starts to develop at the last end of the pressure vessels will accumulate, and when we are doing the reversal flow, switching based on time. Now we also have an AI tool that helps us to predict what will be the optimization of this process. And now it goes back into the skin, and now we start to block rotate. In this way, we have an optimization of the rack. We have an optimization of the hydraulics. Usually what happens when we are doing this design, we also reduce the specific energy. If you compare to conventional, this hydraulic arrangement and the LMH use less energy. Some of the example here, from Singapore to Santa Monica or the US, it's been really in the business for doing these market segments, like industrial, mining, food and beverage. But municipal reuse looks like the largest growing section that we are dealing with. We are doing industrial applications as well. That's close to ZLD. This is our very famous retrofit in Santa Monica, which we take an existing plant and just retrofitted it. So this short video shows a little bit about our technology when it's implemented in a real company is offering, let's say, it's our toolbox, but we are offering a variety of services. Let's say the greenfield is obvious, everybody is interested to buy a new machine, but retrofitting, there is a lot of desalination plants in the world that are old, needs to be retrofitted. We come with a nice solution that's also relevant for seawater double pass. It's also relevant for the beverage, depends on the design. In some cases, we work with engineering packages when the project is either too big, complicated, or whatever. We are able to collaborate with a partner. And brine concentrator, this is something that is going very fast because a lot of our new customers come to see end of the pipe. not only near CLD, GIP CLD. So we are teaming up with evaporator producers and provide a very nice solution, but this saves a lot of the size of these evaporators, if you want. So, some examples of our reference, how much we've been spreading all over, from food and beverage, semiconductor, to municipalities, oil and gas. So it's a platform. At the end of the day, we can take any type of water source and predict the performance. This is one of our installations in Malta, where it's a seawater double pass system, and we can take it from the beginning up to the end with our mother company, but still it's an example where we can take the technology. Example for almost zero chemicals. This is based in Papua New Guinea, middle of nowhere, in the ocean. No chemicals available, the logistics is a nightmare. We are operating here at 88% recovery, no chemistry, there is no acid available, antiscalant is not so much wanted to be used because the brine goes into the shells or to the reef. It's all operated by off-grid system. There is Tesla batteries, there is a PV, and the machine works up to 16 hours a day with no almost no planned intervention, fully automated. But this is an example of how to take resource of brackish water and independently build it with our design. You can see in the front our manifold, our famous valves that change the direction. This is typical installation. We did a very big power station engineering project in China that works. We have recently, last year, we installed a near CLD machine. What you see here is a very high recovery machine that works at the high TDS. We're talking about almost 20,000 microsiemens feet. We operate at 88% recovery. And this is a kind of near CLD or brine technology that we have, and we are able to increase this up to 1500 psi, same concept. This is definitely a growing area of interest, definitely in India, where the regulation of CLD for industrial customers. This is our first retrofit in Singapore. We've taken a Veolia plant, and the owner, Hari Shia, told me, Boaz, I want a pilot. So I said, great, I'm going to send you a container with my 8 kub/h demo. He says, no, 1,000 kub/h demo. Fit it. If it doesn't work, give me my money back and show it works. So he gave me a chance and I taken it. Now we are building, you will see 2 monsters. But it works for 2 years. Now it's going to a tender, hopefully with our technology again. This is what we are building now. This was shipped last quarter. Monster skids. This is one skid. One skid that is built from 3 stories and 5 rows. Mega event. And this is we're really proud about creating new water. And the idea in Singapore, they said, okay, if I'm going to have another 15% recovery in theory, if you build 3 of them, I have another salination plant. So for redundancy, emergency, pending, let's take it. We got a very good deal, but now I'm trying to increase the price. It's difficult. But this is the idea. The idea is to have for the same infrastructure, a better usage of more water that can be extracted from the waste. This is coming for 2027. It's another one, Changi, and it's the same concept. You can see here the amount of wrecks and skids on the motion. Let's say that in this kind of side of the project, the cost of ROTEC here is maybe 3% of the ROI then. the cost to engage is not so high. So the patent and the know-how brings a lot of value. This is, again, fitting a machine that works in Santa Monica for the last 10 years. We came with our machine, increased the recovery with the same equipment. We bought a booster pump, our valve rack, software package, and training. We retrofit. Payback, something like a year and a half. The guys in Nito showed very nice high recovery, 98%. In this case, in Nike, we have this installation that works at 93% recovery. We are feeding here almost 2000 ppm TDS, 100 ppm COD. The machine worked with Nito low fouling membrane, 1 year no CIP. That's for us also was a surprise, but the machine is very well stabilized. So whatever is accumulating is flushed through this system. And COD, POT, and low fouling membranes can bring this. We are now improving our delivery with spacer technology. So we are identifying to bring any type of membranes that we want in the system. That gives us really a very good feeling about how we can operate in different conditions. This is our, let's say, most favorable design and machine because it's really transferable. We ship worldwide. Food and beverage, RTF in Coca-Cola in Spain. We've taken an existing plant by Suez, added our machine on one of the skid. The skid, one on the right, got this red valve, you can see that. And we increase the recovery. That means that it's a very nice facility. We can improve on the existing stuff. It's a major saving and ESG process to the customer. He's able to extract extra water or buy less water. PFAS. This is where we are running into the US. It's a typical project we are building right now. What you see here is a flow reversal comparison to our competitor, CCRO by DuPont. This is the cost analysis of how to treat this site. We are now actually building it. It will take us a year and a half. It's under construction. But PFAS is a big story. If you look at the best available technology now, is reverse osmosis, an FRRO. At 93-95% recovery, we are almost as UF. Our performance is almost as UF. Other places are remote communities, brine operation. So we bring our technology almost to any kind of industry that we imagine. One of our greatest growing markets is DPR, direct potable reuse. We are now testing in the US. Testing of doing a direct potable reuse quality in California. It's going to be sit after an MBR, then it's going to be, the RO is the main component to bring DPR quality. There are about 12 pilots that have been already available through the California regulator. And after that, we are doing AOP, advanced oxidation, and sanitation. So this is a package now goes to our customer in Malta. It's very keen to reduce water and reuse it. And we are doing a very effective energy recovery device of this machine. We supply through our mother company a turnkey job, but ROTEC here is all the top FRRO platform is the ROTEC engineering design. And this is going to be now in the US. We're also being invited to retrofit the Orange County facility because price escalation and energy cost is driving now the payment. We are fighting here with the payment. Okay, technology-wise, cost, it's a global thing, and definitely what we see here in India or in the US is repeating itself. Our pilot program. A lot of our customers are coming back and saying, okay, How I can be sure that it works? Or the US regulators suggest you want to put new technology, you have to pilot, give me a report, send up results. So we have a fleet of pilots circulate around the world. In the US alone, we have 10 units and a team that operates them. We have in India, we have in China, we send to Malaysia. This is probably our best ambassador. Somebody said, impossible. Impossible. If you pay a little bit, we'll show you it works, and then continue your discussion with us about how to do it. So just to summarize, they're really able to bring very high recoveries, typically between 90 and 98. And that means reducing the brine by 50%. Less chemicals, we are cutting the consumption by 50 or 60 or 80%, depends on the application. Less CIP, more harmonized machine, less stages, less moving parts. We are also able to operate like a conventional RO. Let's say that you want to be on the safe side, you can specify that ROTEC can be built on a conventional design. So the customer, if he doesn't want to have a problem, shut off the automation part and go to 75% recovery with standard design. My competitor cannot do it. He has a special purging. If you lost it, you lost it. No special operator training. Behaves like a standard RO. It's smile like a standard RO, and we like the machines. And no proprietary hardware. We're buying the valves and everybody needs knowledge. Same goes for the membranes. We can also have in the big part, we can have a CAP segregator because we already have the valve system. So this block rotation, you can clean blocks without stopping the whole machine or reducing your cleanability. You can clean only the dirty part. You don't have to do the whole thing. Say, okay, Delta P is building on this part. Let's CIP this part. Overall, we are talking about improving the performance. This tool is growing by the day to show that this is how it works. And I'm sure that here in this market, we will do a lot of good things. For the guys that from the evaporator skill, is also using the stuff. So, thank you for your time and for listening carefully to the explanation. He and the MWTS team is available here to explain and to discuss opportunities or challenges. And if you have any questions, I'm here.
Thanks, boss. It was truly excellent, I must say. Something which was missing in Indian context. To be honest, I have been seeing many projects, but this technology is not here. So welcome to India. There are a lot of people who are interested to ask questions. So please.
The exhibition will be open till 7 p.m. today and meet and ensure
Very good presentation, but what about biofouling? Because biofouling is like this 60% of the problem in reverse osmosis. Do you prevent this as well?
Okay, that's a very good point. We are treating it in a better way to cover
due to the increasing number of visitors, the exhibition will be open till 7 p.m.
the
today
fouling area of the
and
membrane.
meet
That bacteria
and
doesn't
the
like
addition of
so
visitors.
this affects the
Due to increasing number of
the
visitors,
bacteria.
the exhibition will be
Biofouling happens less frequent than in other machines. Secondly, we are able to introduce or dose antibacteriicides to the process. So when we are doing the flow reversal, it will clean whatever's been accumulated on the machine. So we're going to treat it in a much better way. We have some samples that we tested against CCRO and conventional,
Yes.
and we very outperform them. Like we don't build the Delta P so quickly, or even it was contaminated after 2 days of flow reversing the flow, we are back in normal. So I can tell you that biofouling is definitely one of our advantages. if you compare to Veolia or DuPont doing this circulation like a cooling tower, you will smear the biological matter on the same thing. It will not resolve unless you do some kind of a CIP or cleaning. And we have some cases that we can show the salt effect and how it's cleaned back. So yeah, we are better fitted for the reuse, and we have done many testing with our piloting, and this can be repeated almost everywhere.
Thank you, boss. Thank you. We have one more question here. Where is the gentleman gone? Somebody was here to ask question. He's not there now. So anybody else asking any question? Anybody else? Anybody else asking question? Yes, you are. Yeah.
If no one is asking the question, so I need to ask one question. Can you discuss related to the energy requirement for per meter cube?
What I can do?
For an seawater RO, SW RO, for conventional RO and flow reversal RO, in terms of an energy, can you discuss energy in terms of per meter cube of seawater RO?
The fact that we are dealing with optimization of the flux allow us to optimize in some cases the energy. If you take a conventional design at 75 or 80% with 4-stage or 3-stage, we will outperform because we have a better hydraulic split. So if you calculate it, we are using the same software that everybody is using for this calculation. You can see by yourself the energy efficiency compared to conventional. When we are doing our design, we are looking into various parameters, the membrane, the type of pressure we want to introduce, what is the target recovery, and what is the target permeate. So if I'm using a tight membrane, I still have the same energy consumption as a conventional. I'm not able to avoid the osmotic pressure needs, okay? But I can improve the flux and the permeability design according to the skid rack. That's possible. We are able to put an energy recovery device on our machine. So technically we collect all the brine and all the energy consumed through the process and do two things. Either we are using an ERI device that allows us hydraulic to return the energy, but we are even more focused with this project I mentioned in Malta. We are able to take a gen drive. Basically, we are able to put an alternator on our brine and recover electricity back into the machine. So we probably will have a lower footprint in our conventional design with 3 types of pumps, and the complexity is easier. One machine.
Thank you, Vince. Thank you. It was quite interesting. And I'm sure, as a consultant, I could recommend you to some of the projects.
Thank you very much.
Now, may I request the team leader from the Murugappa Group